Hey, so in this lecture, I want to talk about coding standards again. We have discussed coding standards before, but I will present a couple of examples in this. And then from here, you can decide on the coding standards for your projects based on the information that I provide in here and keeping these things in mind. Let's do a quick recap on the camel case and Pascal case. Using camel case, the first character is going to be lowercase. The second word in that variable name is going to start with an uppercase again, but with Pascal case, notice the difference. The first character is going to be uppercase. Personally, I prefer to use camel case for variable names, including member variable names, and then Pascal case for type names such as classes, structs, and enumerations. You will notice that the Unreal Engine convention is to use Pascal case for variable names and type names. And actually, let's go and take a quick look at that. So again, different frameworks will have different conventions. We are looking here at the Unreal Engine convention and the CryEngine convention. In the Unreal Engine C++ coding standard for Unreal Engine documentation, we can read why the conventions are important. 80% of lifetime cost of a piece of software goes to maintenance. Hardly any software is maintained for its whole life by the original author. And many of these conventions are actually required for cross-compiler compatibility. Now one thing, if we quickly switch over to the naming conventions, you'll notice that the types and the variable names in Unreal Engine basically uses Pascal case, so the first letter of each word in a name is capitalized. There's also usually no underscore between words. So you can see health, uPrimitive component, and so forth. Template classes are prefixed by T and so on. So it has its own way of doing things. And then also in the CryEngine documentation, if we go to the naming conventions, you will see that the type names, such as classes, have different naming conventions. Classes start with a C, structs start with an S, and these are also Pascal case. Then non-member variable names use camel case. So again, notice the difference between the conventions. So in this lecture, we will look at some of the conventions that I prefer to follow, and you can decide on your own conventions. But it's important to adhere to the conventions as laid out for the particular framework if you are developing for that specific framework, such as engine code. You are modifying the engine code for Unreal Engine, for example. Alright, if you recall, a coding standard is a guide for producing code that is clearly readable and consistent, allowing engineers to interpret the code quickly. Now, different frameworks may have slightly different coding standards. Unreal Engine, CryEngine, and Qt, for example. Unreal Engine being open source, Qt being open source, and you can also get the source for CryEngine. Although I have to say that is at time of recording, I'm not sure what the future will look like for CryEngine. And we must understand and adhere to the coding standard for that particular framework. So if you have the source code for Unreal Engine, for example, and you want to modify that, maybe fix a bug or implement a new feature for the engine, I'm not talking about game-specific code, I'm talking about modifying the actual engine or maybe submitting code for them to fix something with the engine, then you have to understand and adhere to the coding standard for that particular framework. However, it's important to note the difference between the provided libraries or framework code and the code that you write or inject. So in other words, again, Unreal Engine may be open source, you have the engine source code if you want to modify that, but you inject, or in other words, create new classes, game-specific classes, and those are not related directly to the engine code. Those really only relate to the particular project. So it is acceptable to have minor exceptions to the coding standard for the code that you write. But again, if you want to modify the framework or library such as the Unreal Engine, then you must adhere to the coding standard for that particular framework. All team members must know and adhere to the standards for the framework and also to the standards for the project code. So this needs to be clearly laid out. And for newcomers, new members on the team, you may want to lay out why those changes were made in the first place and why those differences exist. Alright, let's continue talking about the conventions that I prefer to use. With regards to Boolean variables, I prefer to prefix those with a lowercase b, and then also to begin the variable name with an auxiliary verb such as was, can, is, has, does, did, should, must, and so forth, such as b has flag, b can run, b was active, and so forth. And then functions that return a type of bool should ask a true or false question, such as bool is equal, are the two parameters equal, for example, and so forth. So it's going to return a Boolean true or false. Next, let's talk about pointers and references. To make it easy for us to see that something is a pointer, some variable is a pointer or a reference, I prefer to start pointer and smart pointer variables with a lowercase p, and then a pointer to a pointer we can prefix with pp. As you can see in this example, we have some pointer to a pointer called pp, ptr to ptr. We have two asterisks there to an integer. Then, taking smart pointers into consideration, we can use pu for the unique pointer. Reading it from right to left, it is up, so unique pointer. And then shared pointers can be prefixed by pes. And then references are prefixed by an lowercase r, but only where necessary. I prefer not to prefix everything, so only in the case where it is necessary to do this. Sometimes the comment might read that you are referencing something, when in reality it is a pointer. Other times it is actually a reference. So in this case I prefer to use an R to make sure that I can see that this is actually going to be a reference. And then we also have references to pointers as we've discussed before in the course. And then I prefer to use the PR prefix. So reading it from right to left, we can see it's RP, or a reference to a pointer. And we have an example, PR reference to pointer, so that is a reference to a pointer to an integer. Then also on C strings, static and then also global variables. The zero terminated C string, so pointer to char or pointer to char constant, I prefer to prefix those with sz, so 0s, reading it from right to left, or 0 string. And again we have some examples, hello human, also with the different ways of constructing that. Static variables are prefixed with lowercase s, whether those are members or not, and then global variables are prefixed with g. We are familiar with this macro syntax already. This is a common convention. Macros are all uppercase with words separated by an underscore character, some underscore macro for example. And then types, enums are prefixed by the e character. We have some enum class, e difficulty for example. As I've mentioned, the name of an enumeration must be written in Pascal case prefixed with an e. Now in the Crayon documentation we can see an example on this, but we should also consider the name of the enumerant, so the members of the enumeration. For the enum classes we don't have any issues since those will not pollute the scope, and so those won't cause any identifier conflicts. But with the plain enumeration, as we can see here, we have an example of a plain enum. Of course, each enumerant will be in the scope that enumeration is in, and so you can have identifier conflicts in that way. So one consideration, as you can see in this Crayon convention here, is to use an e, so a lowercase e, that you will prefix each enumerant. And in that way, of course, you can avoid some of those conflicts. So I prefer to use this convention. Again, give it some thought and decide on what you think is best. Just a quick reminder on the syntax, on type definitions and type aliases here. With the type alias, we use the assignment operator to assign the type to the alias identifier, whereas with the type definition, we specify type def followed by the known type and simply then followed by the alias identifier. And then template classes are prefixed by the T character. We have some templated entity class, and because it's templated, I will prefix the entity identifier with the T, the uppercase T character. Then abstract interface classes are prefixed by the I character, the uppercase I character. Again, we are using Pascal case with types, so class, I, shape. Then for type defs and type aliases, I prefer to prefix them with whatever is appropriate for that type. Because if you think about it, a type def or a type alias of a template is no longer a template, right? You've already specified the type. That is typically why you have a type def or a type alias in the first place, to make your types shorter. So you specify the type, and then you can simply use that identifier. So it's no longer a template and must be prefixed accordingly in that case. A couple of things to think about with regards to passing by reference. As I mentioned previously, we can prefix with R, we can prefix references with R, but when we use references with formal parameters, so when we pass by reference, then what you can also do is you can use in and out, so we can prefix the function formal parameters with in and out, depending on whether the function is expected to write to, or in other words, modify the argument. Speaking from experience working with Unreal Engine, this really makes it easy to see what is going on. and what the function needs, takes in and gives out to you basically. So we can prefix function formal parameters with out if they are passed by reference, and the function is expected to write to that value. So instead of using r, the r prefix, we can prefix out. But what in the case if we simply want to pass something in, and we pass something in by reference to const, so the function is not going to write, or in other words modify, the argument? Well, in that case we can prefix the function formal parameters with in, and then of course also taking the boolean into consideration. If an in or out formal parameter is a bool type, then we prefix, or in other words we put the b character before the in or out prefix, such as in this example here, b out is attack power equal. So that's a long parameter name there, but hopefully it illustrates the point. And then just a silly example, we have some function void activate enemy attack, and the function will write out to a boolean for the first formal parameter. So we have b out took damage, and that again is a reference to a bool. Then for an example that is not special, the second parameter here is chance to hit. That is a double. So again, I'm not using any special prefix for that. And the final one is a reference to an int, so that is out damage. We can get the damage out of that function. Of course, you can also return the damage. So instead of returning void, you can return int and so forth. But if you recall, we typically don't do that with these kinds of functions. We typically return void and then we return or modify through the reference parameters. So again, this is something that you will have to decide on. You can use r for reference, but it's easier to read whether something is going to give you something out or modify that, in other words, or whether it's going to simply take something in. Now, I don't prefix everything with in or out. Again, it's only in the case with references, for example. Another very important consideration is the layout of the C++ classes. For example, I prefer to follow the CryEngine convention on that as laid out in the documentation here. You can see the layout for C++ classes should follow the format, as we can see here. Firstly, we avoid having multiple classes in the same header or source file, with some minor exceptions. For example, classes which are nested inside other classes, and so on. Then we also prefer to use a namespace to a class with only static member functions. So again, use namespaces where that makes sense. It's not necessary to put everything in a class. And then also prefer to follow this basic layout as you can see here. You may have noticed this in the lessons on object-oriented programming in this course. For example, we have the class and then the class name, and then we start off with public, protected, and private. Alright, so in that order. Now, of course, you can have multiple ones as they have here. However, I prefer to have one section each. So public section, protected section, and a private section. But if it's really complicated, then of course you can break it up in this way as well. So now you have your methods, and you want to start in the public section with your constructor and destructor, of course, followed by your protected and private section, and then eventually your members. We should also use the virtual and override keywords for virtual methods in derived classes. So not just virtual in the base class, right? Where we override that, we also want to provide virtual and override. And then of course, along with that, the basic things, avoiding the use of public member variables in classes. Those are fine in structs, but not in classes. We want to try and limit access to the members of classes. We want to access those through functions using getters and setters as discussed in this module. Then in header files, I prefer to use the pragma ones instead of the older include guards, if, in, def, define, and so forth. So again, I prefer to use the newer pragma ones. Also important in header files, we use forward declarations when possible, and we don't just include stuff because you need to have that class name available in the header file. So use forward declarations again when you use pointers, for example, when you use a pointer to something. Then you can simply use a forward declaration. It's not necessary to include stuff in your header file when you use pointers. Then for the order of includes in the source file, I prefer to include the header file, the associated header file first, of course, followed by whatever other headers I might need. And take the layout of your classes into consideration and make sure that that is consistent across the team to make it easier for the reader to find what they are looking for. A couple of examples from one of my Unreal Engine projects, in this case the Apple Picker project, which is part of the Unreal Arsenal modules. And in this case, I'm looking at a constructor, which will set the default values. and we can see we have the constructor, and then we have a colon, so we have the initialization list, a comma separated initialization list, and this is simply going to initialize a couple of variables for us. Here's an example of a boolean. It begins with a lowercase b, but more than that, I want to demonstrate something else that you have to take into consideration, and that is basically how you will format your code. So for example, if you have a long initialization list like this here, what you want to do is you want to place the typing caret right before a comma, before the next one that will go off of the screen here, and press enter, and that should be indented as well, in case you want that to be indented, and so that makes that easier to read like that. Here's another example with a function that I pass in some arguments. So different example, I pass in some arguments, but it's clear to see what arguments I pass in based on the formatting here. Another one with more arguments. I set the timer on a particular timer, this game start countdown timer. So it's just some function that I invoke here, and I can pass in these arguments. It's easy to read and easy to see the arguments. I don't have to be scrolling to the right here to see the arguments as a reader. Alright, and also one more example here in a header file. I mentioned I use Pragma once. You will notice that that is also default if you code in Unreal Engine here. A couple more things, don't mind all of these macros and stuff. If you are not familiar with Unreal Engine, these might be a bit strange to you. Don't worry about that. If you're interested, go and study the Unreal Engine modules. We can see that we do public inheritance here. This publicly inherits from something called Apple Tree Element Base. Notice that we have to include the header for that. But if I scroll down, we can see here we have a pointer to something called a uNiagara system. Again, ignore the macros. Here we have a variable, a pointer to a uNiagara system, and the variable is called Apple Destroyed Particles. Notice that I forward declare that using that class keyword. I don't have to include the file for that particular class because it's a pointer, alright? But again, if I derive from a particular class, then I want to include that header. Looking maybe at another example, the tree base. This publicly derives from the Apple Element base class as well, and that is included. But here I have this a Apple base forward declaration. So you can forward declare like this, because this is basically used for a pointer as well. And then in the Apple base header here, we have a different way of doing that right here. Also notice that we have these virtual functions that are declared in a parent class, and we are overriding these virtual functions in this class. So we provide a virtual and override. So again, these are things that you have to consider for your projects, but you also have to pay attention to the conventions for the particular framework. Another example from the CryEngine documentation, you want to avoid long function parameter lists. So here is a good example. Do something, you have a list like this, alright? Indented, each one on their own line. Some additional prefixes that you can take into consideration include in the CryEngine documentation here, for example, in the deprecated section, you can see we have F for floating point numbers, float or doubles, N for an integer, and so forth. Now we do actually use B here, lowercase b, but in the case with CryEngine, they've actually deprecated this, and will instead use auxiliary verbs such as was, can, in, and so forth. So the problem that I have with prefixing everything such as F for float, N for an integer, and so forth is that you want to prefix, I almost want to say special variables and types. You don't want to prefix everything. It's unnecessary to prefix everything, but these are some additional options that you can consider. Also moving up to the member variable names, you can see that non-static member variables should be prefixed, should have this m underscore prefix and use camel case, unless the struct or class has only public member variables. Alright, you can see some examples here. Take this into consideration. If you use this convention with the m underscore for members, then in the member function definitions, it is handy not to have to worry about conflicts with parameter names, for example. This convention also makes it easy for the reader to see at a glance that some parameter or result of some calculation is being assigned to a member of the class, for example, or that the member of the class is being modified somehow or used for some calculation. Also looking at the naming conventions in the Unreal Engine documentation, template classes are prefixed by T. You can see an example here. A type def of a particular template is no longer a template and should be prefixed accordingly. For example, type def, you have some array type. Unreal has its own array type. Then you give it this different name here. It starts with an F. So Unreal is going to use an F if it is a type def or a struct. Whereas if we go to CryEngine, you'll notice in the documentation it states it is acceptable to use a character T as a prefix to indicate a name that refers to a type. This can be useful when you mix type and non-type template parameters. You have some type here such as a vector, and then you do the T prefix. A vector is kind of like an array, it's a container. We'll talk about vectors in a future module, but notice the differences again with the conventions. So ultimately these are things that you have to decide upon. So there are many things to take into consideration with regards to naming conventions, even things that you may not have thought about. For example, from the CryEngine documentation we can see in the CryEngine naming convention, all names and comments should appear in or should be in American English. You might prefer international or UK English, in other words English, and I prefer that English as well. However, you and your team should decide on that or stick to whatever existing conventions there is on that. So that is going to wrap up this lecture. This does not cover everything. So for example, of course, I prefer to initialize all of my members, even if it is using empty braces. We want to initialize our pointers to null pointer. We always want to check for null pointer before we actually use that pointer or try to dereference that pointer. Then we should also pay attention to conventions with regards to comments and how to comment things properly and so forth. Alright, so I just wanted to give you a basic idea. I did not follow all of these conventions within C++ 101 and 102, but I may do so in the next iteration. This was not meant to confuse you, but to show you that different frameworks use different conventions for different reasons, and that you have to pay attention to the framework conventions, but that you can be a bit naughty and sort of change that for various reasons for your own project. That is for your project-specific code. Alright, so that is going to wrap things up for now. I hope you found this useful and that it will help you make some of those important decisions moving forward. And I will see you guys next time.